Hey everyone, today I'm going to show you how I made this text particle effect using the Geo Text operator in TouchDesigner. And if you stick around to the end, I'll also show you a plugin that I made that will get you this effect with just a drag and drop operator. All right, let's get started. So the first thing I'm going to do is set up my variables, starting with, I'm going to have a replications. I'm going to start that out just with one for now. And then I also want to have a width and a height. These are going to be actually my resolution. So let's do 1080 by 1920. And so let's put that onto a null. And I'm going to call it variables. I'm going to right click and view and drag that up to my top here, so I can access those for later. Okay. What next? Okay, I'm going to get things set up for the text that I want to replicate. So I'm going to start with a text dat and put some subtext in there. I'm going to say subscribe. And I'm going to bring this into an evaluate. I'm getting an error first because I'm going to actually, in this evaluate, I'm going to reference my replications, and I'm going to say me.inputCell.val times, and then I'm going to make sure this is an integer, and close my parentheses here. So me.inputCell.val times integer of my number of replications. This should, using Python, replicate however many replicants I put in there. So if I start out with 10, actually, I should have 10 subscribes. I'm going to add a space after my text here. And I'm going to go ahead and put on word wrap, but it's not wrapping. Never mind. Okay, so eval again. I'm just going to separate this out just for clarity's sake, but because when I replicate everything, my geotext is going to have word wrap on as well. And I don't actually want it to do it by word. I want it to do it by letters. So that way my letters fill out the entire thing. This is an option you can choose to put in or not, but I'm going to add a space in between all my letters by using a little bit of Python here. So in quotes, I'm going to put a space, dot join, and then in parentheses, I'm going to say me.inputCell.val. Okay, so now I've got my spaces between everything. I'm going to put this into a null, and I'm going to name this null text. Great. Okay, so this is my text that I'm going to use to replicate into my geotext. I'm going to move this over to the side a bit. Okay, so next, let's go ahead and bring in our geotext and talk about what this is. So geotext essentially allows you to create text in geometry, but it gives you more options than what like a text SOP would give you. And I'll get into exactly what that means as we go, but the way this works, I mean, it works kind of just like a geo, like a regular geo operator. So if I had a camera and a material, we can do constant and then a render, you know, I can render out that text in a similar way. So while I'm here, I'm going to go ahead and set up my render with my width and height. So let's drag those into the render. Okay, so how am I going to get this text into here? So a geotext, there's really a lot you can do with geotext, and the way you can see kind of the variety of things, and the obligatory mention of this is the operator snippets. So if you haven't discovered operator snippets, you should definitely check them out. There's so much available here to show you every operator and how they're used. So geotext has a bunch of different examples in here of how you can take an input table with the information about the text and use that, as well as it's got this great way that you can add a local transform X, Y, and Z. So that way, like with this example, if I activate the slider, and I move it, I can actually transform the text just by the amount that's in this LT or this LTX, LTY, LTZ. And this is actually where we're going to use some of that in this tutorial. You can also, you know, render text in 3D space this way. Lots of really cool stuff. that you can do by putting text into 3D environments with GeoText. We're also going to use some of this section here as well, the way that brings the text into the table. In fact, let's go ahead, and I know, for example, I'm going to be using these two DATs in my program. Maybe I should explain what this is doing first. So this is taking a bit of text and let's get rid of my parameters. It's taking a bit of text. Anytime it's changed, it uses the geotext and it asks this geotext, if I use this text with your parameters that I have set up, what all these settings are, I want you to give me that information so I can put it in this table. And I also it's asking how it would lay out the text, and then using here, this example is using some math to decide how to rotate it around this sort of column. And what's nice about this is GeoText will add on things like word wrap. So if I add more onto the end, you'll see here that it actually did a word wrap and moved down a line. So some pretty powerful features for things like how text should be lined up. All the kerning, all the different font metrics and things like that are built into GeoText, which makes it really powerful. And specifically, there's also a function here called this layout text is what it uses to say, give me the information that this GeoText would or the way that this GeoText would lay out the text if I call this function. So I'll review this again as I move it into my project here. So I copied over table X and text2 from that code snippet, and I'm going to use them to update this GeoText. So right now, if I click on my GeoText, I can see that my text values are being set by this this box. So this will be updated there. But instead of this text mode, I want to change it to a specification dat and chop. And to know what this specification dat or a specification chop, what it should look like, you can obviously look at the operator snippets. You could look in the documentation, that talks about all the different columns that you can add with text for the actual letters or words you want to use, the X locations, font size, TX, TYZ locations, font size, font color, and as I also mentioned, the local transform, local rotation, etc. So so those all can be put in this table and fed into the specification set. So this came from our operator snippet. So this is already formatted correctly. So I know if I add this into my specification stat, it's going to bring it in and render okay. But this is obviously not what I want my end project to look like. So let's go into this code here, and we're going to simplify this a lot. So if you're scared of Python code, we're going to make this really simple, and I'll explain kind of what each line is doing here. So I'm going to go in and I'm going to change quite a bit of this first, and without explanation, just to get it simple. So I'm going to delete this function. I'm going to remove the tab from removing that function. I'm going to remove all this math here, and then just have these lines. I also don't need this radius. Great. Okay. So to walk through these lines here. So first, I'm going to set a variable called table X. That's going to be this stat. And then every time I run this, I'm going to clear this table, but I'm going to keep the first row, because this first row of data are things that, this is just the header name. So, which also reminds me real quick, I'm going to get rid of the columns that I'm not going to use, because I'm not going to use any rotation. I'm going to right click and delete these columns and these two extra ones that are on the end here. Okay, so that means, every time I run this, we're going to clear the whole table except keep the first row. And then, and then I'm going to get this layout data. And the layout data is going to say, get my geotext, and I need to rename this because my geotext is called geotext1. Oops, geotext1. And then run this function layout, and I'm going to send it some text. So I haven't set what this text is yet. So I'm going to set text equal to my operator called text. Operator text dot text. So many times I'm using the word text here. So this is saying the text inside of this dat. So this will take that string and run it through this function, and it'll give me data for each of my characters that I give to it. So in this for loop, I'm going to go through that whole string just piece by piece, so the entire length of the string, and then I'm going to rename this here. So I'm just going to do an X and a Y. So the X value is going to be the layout. So this letter's origin X location, and this is going to be the Y layout origin Y location. The Z, since I know I'm just going to be doing everything in 2D space here, it's just going to be 0. And then I'm going to write to this table all this data that I just got. So I'm going to first put whatever that letter is, whatever the text is, the X, the Y, the Z location, and then I'm going to get rid of these rotation values that I got rid of the columns for already. Okay, so I think this should work. Let's give it a try. So this should, anytime I run it, take this text and say, Geo Text, tell me where you would put this text with your current settings. And then I put that data into this table, and that table is what the renderer part of this Geo Text will use to display the text. I know it feels a bit circular because I'm using that function to say where you would put something, and then I'm using this table to say, yes, actually place those texts, place that text in those spaces. But that's the way this works. So I'm going to click on my script here and hit Command R to run it, and you'll see, okay, I got this nice, all my subscribes all written out. Okay, what next? I'm going to rename this. I'm going to say update start positions, because this is my start positions of where my letters will begin. What else do I want to do? I know, let's look at how these are rendering right now. So this Geo Text, obviously it's writing out one long line, and I want it to do all the word wrapping for me. So I'm going to turn on word wrap. You'll notice that does nothing to this. That's because my location isn't set by this right now. It's set by whatever's coming back from that function call. So what I want to do is every time I make a change on my geotext, I want it to update automatically. I don't want to have to like do this and like I change that and then I run this script and now it's word wrapped. I don't want to have to do that every time. So I'm going to use a parameter execute. So if I do a parameter execute and I say, okay, this is my operator I want to reference, and every single parameter in there, so I'm going to do an asterisk, and that means every time a value is changed, I don't need the pulse, every time the value is changed, I want you to run this update start positions. So in on value change, I'm going to go in here and say op, and I'm going to copy in my update start positions operator name, and I'm going to say .run. So that's the same as me hitting Command R on this guy. Okay, so let's change some more values and see what happens here. So if I change the font size, for example, that means it's running the script. Okay, so that's looking correct. Okay, another thing I want to do is anytime I change this text, so if I add some more text onto this, that also did an update. So I want to do a similar thing anytime this changes. So I'm going to use a Dat Execute for this to say, based on when this dat changes, I also want to add op update start positions .run. Okay. Let's change it one more time. Let's add comment. Okay, so now that's updating. Great. Okay, where are we at now? So let's go into more of the rendering here so we get a good preview, and then we'll get into how we're going to move and affect these letters that are being rendered. Let's first of all, we'll drag out our render into an out, and then I'll right click and hit view, shrink it down, and bring it up to the side here. Okay, so let's go into geotext. So I know I want to change a couple of these things. Right now, I'm rendering the text in this bottom right quadrant, and yeah, I want to be able to, well, no, let's just keep it how it is right now. So I know my width and height is a 16:9 layout size. So let's set my box size about that size. These are kind of weird. It's like a weird box size to say 20. It's 20 units wide, and I think that's just because it's for the font size like reference. It keeps it. I actually don't know for sure why they did it this way, but I'm going to kind of stick around the same sort of value just so things don't get too weird too quickly. But I know my ratio here is 16:9 or 9:16, so I'm going to say the width is 9, the height is 16. And then, let's start tweaking some things. So I'm going to bring my size down so I start seeing the number of letters that I want. I'm going to start moving my camera around. Let's see, I want to move the top left to that top left corner. And let's start, let's up our replicants so we kind of fill up the space a little better. Okay, let's bring that out. Just kind of tweaking. And I don't want to have, you know, more replicants than I need because I don't want to process too much data at a time if I don't have to. Okay, so let's see. Let's keep tweaking a little bit more. I want more letters. Yeah, let's do that. And then let's fill up the page with that, and we'll start. This is a good starting point. Okay, great. So I'm getting a render of all my letters across everywhere, and here I have all the values for each of these letters, and including my spaces. I've got their X and Y and Z locations. So this is what I'm going to use then to then affect themselves. So I'm going to use that local transfer X and local transfer Y values that I can add into GeoText to then move them from their original locations. Okay, so the way I'm going to do that is I'm going to take this dot, I'm going to move it just to a null just to make things, get things in the right place here. Okay, and then I'm going to convert this first to a chop, so a dot to chop. I'm going to say I'm going to do output per column because my data is all in columns here. And then my first column or my first row is names, so that should update my names to be correct here, TX, TY, TZ. And okay, let's bring that into a null because we're going to convert this now to a top because we're going to use some UV lookup to reference a force texture of how to move, of the way we want these letters to move around. Okay, so continuing on with this, so chop to top, I'm actually going to change this RGB, and then I'm going to fit it to a square so that I can see what's going on a little better. And okay, so I get this kind of blown out red. That's because all my red values, they're up way high, they're way above, you can see in this corner here, they're way above 1, and my green values are going negative actually. That's also something that GeoText, the way it understands text, even though, yeah, it's doing everything below in the negative numbers here. So let's remap that so that's nice normalized UV values for me. So using a math, I'm going to look at this. I mean, I can also reference my. It should be the same as what my layout box values are here. So 9 and 16. So I can say instead of from 0 to 1, I'm going to go 0 to 9 to 0 to 1, and then sorry, not that one. In the red, sorry, in red, I want to do from 0.9 or 0 to 9 to 0 to 1, and then the green I want to do from 0 to negative 16 actually to 0 to 1. Okay, so this looks a little more of our normal, you know, red, green, and yellow UV map. So let's make these nearest pixel, and yes, okay, let's go with that. Okay, so now I have my UV sample points. Now I need a force texture to go from. So let's just use a ramp here, and I'm going to. Let's use the same width and height just so it keeps the same shape. And then I'm going to do a circular. Let's do a period. Well, let's say I know I want to mirror these. Let's do a period of, yeah, let's do 1/3. And then I want to phase it, animate the phase, so apps time dot seconds. Let's just try that. Yeah, that's pretty good. Okay, so I'm going to make this 32-bit mono, and then I'm going to use the slope of that to get some force values that are just red and green values. These are just, you know, mono values. I want to turn that into a slope, and I want them to go positive and negative. So I'm going to make the 0.0. I'm going to take the green from the vertical luminance. I'm going to hit A and N so I can see my values. Okay, so now it's just a mono right now, so I need to change it to 32-bit RG. Now I have my red and my green values. If I take it off A and N, you don't really see a lot here. And to bring those values up to more manageable values, I'm going to put in a limit, and I'm going to normalize it from -1 to 1. Okay, so now I've got these nice strong force values, and this is let's put that into a null. Let's call this force. Oops. Okay, and so now I'm going to use these points to then sample from here where I should move each of these letters. So let's use a remap to do that. And the first value is always the source, and the second one's the UV points. Then I'm going to take the resolution of that from the vertical source. So I just have one point for each of these UV values. Change it to nearest pixel. Okay, and so yeah, that's actually pretty much it here. So I'm going to say put a null in here, and then I'm going to convert this back to chops. And instead of RGB values, I'm going to go ahead and rename these now to LTX, LTY, LTZ, because it's the amount I want to locally add or subtract to the X and Y values here. So let's make sure this is, that doesn't matter too much. Okay, so yeah, let's take that out to a null. Oh, I know, I forgot. This is only sampling a single line from this image, the middle line here at 0.5 V. I wanted to sample every pixel. So instead of this row crop, I'm going to do the full image. And that's going to give me these separated channels. I want them all as one channel to work correctly with my geotext. So I'm going to insert a shuffle. And then I'm going to shuffle them, sequence all the channels by name. That'll automatically bring back the correct lineup for these. And I'm going to show you this error because I run into it, and just so you recognize it if you do this. So if I look at this specification shop and I pull in my null, which has the correctly named variables, and I go back here, I see there's an error, and the error is going to say the length of my specification chop must be equal to the number of rows in the spec dat. So it's saying that, you know, my number of rows here in this table are not the same as my number of samples here, and that's because I've got this sort of like these extra pixels up here up top that came in when I squared off. You know, when I squared this off, I have these extra pixels. So an easy way to get that fixed is to add in a splice. I'm going to say output the trim section, and then I'm going to say the trim length for my splice is going to be my op table x dot num rows. So now, if I look at this, my rows are 1364. My splice, though, we're going to have 1364. But I forgot one other thing, is that there's a header row in that table. So I'm going to subtract 1, and right there we've got something happening. Okay, so let's tweak a couple things right now. This I didn't add in an ease in and ease out, so that way all my slope is very linear right now. So I'm going to change my ramp to be ease in, ease out. It's already looking a lot better. And I'm going to add in a math here before my force null. So math, just something I can tweak like the strength of this effect. There we go. Very cool. Okay. So so yeah. So now we've got things getting pulled in, pulled out by just the slope of this. Some other things we could do here. One of the things I like to mess with too is, like, instead of using the force going in and out based on the slope, I can make it a perpendicular slope using the same strategy I use to make curl noise. So I can reorder first. If I switch my red and green, and then I take a math, and I in my range I invert my red from -1 +1 to 1 to -1. Then when I bring that in, it'll kind of spin things around. Okay, and I think this problem here, so it's not quite doing it right, and I think that's because of our y being negative. So let me see here if this fixes it actually. So instead of going from 0 to -16, and then instead of 0 to 1, I'm going to go 1 to 0. There we go. So because our numbers are going from 0 down to -16, it was inverting the sampling positions of the y. So this will fix that, inverting here on this math before I do the remap. Okay. Cool. So what else could we do with this? I mean, really, we could put in any other slope into this ramp. I mean, we could we could add our own little force circle as well into this. So I'm going to make my same little force field texture that I've made in other tutorials. So let's add a ramp, set the resolution only. I'm going to create a circular ramp. I'm going to say hold, and then on the middle I'm going to make it white. On the outside I'm going to make the alpha 0. I'm going to make this mono plus alpha 32 RG. Okay, and then I'm going to make 2 more ramps. And this is going to be a radial ramp. Let's take it only the resolution. A radial ramp. Let's go into our dat values and say we want this from -1 to +1 in the red only. Oops. And this can just be a 32 RG because I'm going to copy and paste this. And then the second one, I'm going to do the same thing but for the green values. And then, okay, I'm going to make this a mirrored. The period is going to go to 0.5, and the phase is going to go to 1. I explained more of how this works in my particle flow field, the kind of flocking effect tutorial. So if you want a deeper explanation of why I'm using these values here, you can see that in there. But essentially, I'm building a force texture that's going to push from the center point. It's going to push particles up on the green, and in the Y space, it's going to push it up or down based on it's above or below. Here, it'll push particles to the right or particles to the left out from the middle, and then I'm going to multiply it by this amount to make it distance dependent. So, okay, let's combine these together using a reorder. Input 2 is going to be my green, and then I'm going to put a transform in here before this in case I want to shrink it, and then I'm going to multiply by this input, and let's see, 32 RG, that's great. And then let's take that and let's add it here to our other force. Okay. And then I'm going to move it around using a transform, using noise chop. I'm going to just create some random XY positions here. So in a noise chop, I'm going to go in, make a channel called X and one called Y. I'm going to turn on time slice, and then I'm going to reference that inside my translate of my transform. Let's tweak this a little bit. So the period, I want it to be a little slower. So let's say like 3, let's maybe 5. The amplitude, I don't want it to go off screen, so let's do 0.5 just to kind of keep it around. Cool. So already I'm seeing here, I'm getting my text moving around. And of course, after the fact, I can go in and add more post-processing stuff. We can do a basic like RGB delay on this. So bring in the RGB delay, plug it in. Like, these are usually way too high for me, so I'm going to do like 5, 3, and 1. Cool. So yeah, really fun to play with this geotext stuff. I think there's really a lot more things we can explore with this to make some cool kind of motion graphics type animations with text, and also ways we can make it interactive and other things like that. So anyways, I hope you like it. If you make something with this, definitely tag me in your posts. I will reshare everything anybody makes using my tutorials, because I think it's so awesome. I love sharing people's stuff when they make projects with the things that they learn from me. Also, be sure to subscribe, and if you want to see more of my tutorials in the future. Also, if you want the project file for this, you can support me on Patreon. I have all my project files there and all the tools I made, including the tool that I'm about to show you here. That is a way you can get this effect just out of the box, just by dragging and dropping in the effect. Yeah, thanks again, and we'll see you at the next one. Okay, before you go, I do want to show you this tool that I've made that specifically makes these type of geo text animations a little more easier than all the code and things I showed in the tutorials. If you want to use this tool, it'll be available to all the people that support me on Patreon. You'll see here inside of this tool, you can do things like easily change the font size of the text. The first input is just a text stop, so or a text dat. So if I change, add text in, it changes there. Also, the force is the second input here, so I can create any sort of red and green valued piece of data that will affect the force. I can change the strength of it by how much the force will affect the text. So if I set it to 0, you'll see it'll just stand still. Then I can, say turn it up, turn it down, change the font, change the line spacing, change the tracking. These are all settings that are found in the Geo Text. If I dig into this, clear this error, try and fix that before I launch it. You can actually go in and edit whatever you want. Right now, one of the limitations of this is to make sure that the framing is always right when you change the resolution. I have the camera set to orthographic, but if you turn that off, you can do your own sort of zooming around and actually do 3D translations or transformations with the force as well. So anyways, hope you get a chance to play with that. And again, like I said, show me what you make with it. I would love to share it. And thank you guys so much for your support. One last thing before you go, like I've said, if you haven't already subscribed to this channel, also support me on Patreon. But I am also a freelance TouchDesigner developer. So if you have a job that you're trying to make that you would like some help with, reach out to me. My contact information is in the description, and I would love to chat with you about how I can help you out with your TouchDesigner projects.